So a quick run through of this question in SOLIDWORKS. So on part A, on draw the given elevation. So we have the cone set up. Okay, then we have to set up the sphere in its construction position. So there's in its construction position, right there beside the cone. Here's the elevation of the solids in its construction position. There's the angle bisector. Okay, there's a center point that's up 30 mil from the XY line. And this line that establishes the point of contact makes a 90-degree angle with the extreme generator. Here's the plan of the solids in their construction position. Now, there's what you call it, a hidden detail line underneath what you call it, that point there, or that circle there in plan. So there's our plan view. Okay, now then we're going to rotate what you call it, the solid or the sphere into its correct position. So it's rotated about here, about the axis, okay, of the cone. So that axis of rotation is there, and it's rotated until it sits on a 45-degree line that goes through the axis. So in plan, so I'll bring up the plane. If I can find the plane, there we go. So there's the line that the sphere is resting on. Then we have the true elevation and plan. So that's the true plan there of the solids, and then there's hidden detail in there. It's just not, haven't got it shown there. And then in elevation, there's what they look like, black there. Okay, and the cone around the cone, so you can see it there. Okay, that's the arc for finding the point of contact. So there we have the hidden detail in there, and then the point of contact in elevation is brought over from the original one. Okay, straight across from the original one in elevation. That black arc there is actually that red line in elevation. So it's rotated onto the line and then brought straight back up. So it is. Okay, so that's the 3D model done there. So welcome to the 2019 Section B question B4. The elevation and plan of the sand bucket and beach ball are showing. A 3D graphic of the beach ball is shown, also showing. The bucket and the ball consists of a truncated inverted cone. So the cone is upside down with the word inverted, and then truncated, cut by the XY line. The sphere rests on the horizontal plane, so on the XY line, and is in contact with the truncated cone, so it touches the cone. The bucket has a semicircular handle S. Draw the position as shown in plan at 45 degrees and elevation here, so it appears as an ellipse in elevation. Part A, draw the given elevation and plan showing all constructions and points of contact. So I'm going to start with just the truncated inverted cone and the sphere. So I'm going to start off by constructing the outline of it, okay, the cone, constructing the sphere in its construction position, find the point of contact, dropping it down, and then I'll rotate the solid into its final position. So I'll draw the truncated cone elevation there, XY line, set line, be added in here. Height of the cone is 70. 35 either side of the center line for the base. Angle 75. Now we have to establish the point or the construction sphere in elevation, so we're going to take our compass, bisect the angle, so that compass is set at any radius, so swing from each of the arcs, join the crisscrosses back to the vertex of the angle. The radius of the sphere is up 30, so we're going to go up 30 here. There's the center point of the sphere in its construction position. Then to get the point of contact between the cone and the sphere, look, line your set square up with the extreme generator of the cone. You can put your T-square or another set square underneath it, hold the T-square or second set square down tightly, slide the set square along here. Here's the point of contact. Now, the center point of the sphere in plan lies on a line with the apex parallel to the XY line, because there it's touching the extreme generator there in elevation, so the extreme generator is here in plan. So I'm going to drop this center down, and this is the cone or sphere in its construction position. The radius remains the same. We're going to rotate it into its final position in a moment after we establish the point of contact in plan. So there's the point of contact in its construction position. So 45-degree line here going through it. Okay, that's where the center point is, or that's where the centers will be on the 45-degree line. So we're going to put our compass on the center of the cone in plan, and then rotate it down. That's the center point there in plan. There's the true point of contact in plan. So now we're going to bring both points straight back up to elevation. So here's the center point in elevation. And just go straight across from the point of contact in elevation. That's the true point of contact. Now we shouldn't have heavied in that line there. So we're going to draw in the sphere in its correct position here. So the radius remains the same at 30 millimeters. And then in plan, this is where it is in plan. So I'll add in the heavy and hidden detail. So there's a heavy and hidden detail and the true points of contact. Okay, so next I'll do the handle. So the handle is represented by a 45-degree line in plan. That means in elevation you're not looking perpendicular to the handle. So if you look at a circle, okay, other than 90 degrees, it appears as an ellipse. So the major axis, okay, is essentially the radius of the radius of the cone, and the minor axis is where the line hits the curve back to the center. That's the minor radius. Right, so that's a 45-degree line in plan. Okay, now here's a point on a minor radius. So drawing the minor circle, drawing the major circle, divided into 60-30. Where the division lines hit the major circle, the big one, we're going to go parallel to the minor axis towards the middle. And where they hit the minor circle, we're going to go parallel to the major axis away from the middle. And we're going to freehand sketch them in. So part B, we have to draw the development of the conical surface A. Okay, so I'm going to divide this circle up in 60-30. Okay, I'm going to take this length here as I extended this line on. I'm going to swing it over here wherever I want. And then my divisions where I've divided this up into 60-30, I'm going to step them along 12 times. Okay, so for the base of the cone then, just take half of this here from elevation. Okay, head over to number 6, step here, and then, okay, we can draw in the curve, or the base there, with the radius of that circle, right?
Okay, so part C, draw the development of the semicircular handle. Now this essentially is here the true shape of the handle, because when the semicircle goes from here to here, it's like the handle was there. So we have to just unfold this curve here. So you need to have it divided up into 60 30, okay, in elevation. So I can just draw a horizontal line up here, start wherever I want on it, then compass, set to this distance, I'll level the points.